All right, so this is the angle postulate and theorem quiz. We're going to start with number 1, and there's a bit of setup here because I do need to draw out the lines. So you have two lines here that are parallel to each other, and they are line AB that is parallel to line CD, and then you have a third line that is cutting through them both, which is line, in this case, EF. So again, AB and CD are parallel. And this gets you 8 angles. 8 angles form. 1, 2, 3, 4, 5, 6, 7, 8. Those are the names of the angles. And you are given angle 6 at 80 degrees. And you're asked to find all of the other angles. Okay, well, angle 6 right over here is 80 degrees. And the first thing that I would use is the vertical angle theorem, because right over here you have essentially two lines that are cutting across each other, and angles that are opposite to each other or vertically aligned are going to be equivalent. So angle 6 and angle 7 are on opposite sides. So angle 7 right away is also going to be 80 degrees. So it's an easy one. Angle 7 is going to be 80 degrees. Then I'm going to use the corresponding angle theorem. And the corresponding angles for angle 6 is angle 2. So angle 2 is also going to be 80 degrees. And then the corresponding angle for 7 is angle 3. So I'm going to use that to also get the 80-degree answer here. So that's all I can do within the two postulates and theorems available to me. Then I can look at the supplementary angle theorem. I can say that, hey, if I take, let's say, angle 1 and add angle 2 right up here, they will equal out to 180 degrees. And I know angle 2, right? At least I found it. It's 80 degrees. And I could do this with like angle 6 and angle 5. I probably should have done that. I'm going to do that with angle 6 and 5 because those are my original angles, or at least 6 was. So I'm going to say angle 5 plus angle 6 equals to 180. But again, angle 1 and 2 would work out the same. And I was given angle 6 to begin with. That's why I'm using that. But again, I found out angle 2, so it's not a problem. Equals to 180, and then you just subtract 80 from both sides. And you find out that angle 5 is simply 100 degrees. Now that you know angle 5, right over here is 100 degrees, I'm going to use the vertical angle theorem to find out that the angle that is vertically aligned, which is angle 8, is also 100 degrees, right? Because angles on opposite sides are the same. So angle 5 is 100. Angle 8 is 100. And then I'm going to use the corresponding angle theorem. So if angle 5 and angle 1 are corresponding, that means angle 1 is also 100. And angle 8 and angle 4 are corresponding, so angle 4 is also 100. So congratulations, you found all of your missing angles. Half of them are 80, half of them are 100. So that's number 1. Pause that if you need to, and let's move on. Number 2, again, a very similar problem. You have yourselves two lines that are parallel to each other. Oh, can't do straight lines. Okay, there we go. And those two straight lines are KM and N and L. And they're being bisected or crossed by a third line, which is WZ. And that forms, again, our 8 angles. And they give us one of the angles. Angle 5 is given to us as 110 degrees, and we're asked to find all the rest. So angle 5, which is right here, is going to be 110 degrees. And again, I'm going to use the vertical angle theorem and find out that the angle right opposite to it is also 110 degrees. That starts us off. So angle 8 is also going to be 110 degrees. Then I'm going to use the corresponding angle theory, and these angles 5 and 1 are corresponding. So that means Angle 1 is also going to be 110 degrees. And angle 8 and angle 4 are corresponding. So angle 4 is also going to be 110 degrees. So that's half of them. Now, in order to find the rest, I'm going to use the supplementary angle theorem. I know that these two angles are supplementary, 5 and 6. So I'm going to say that, hey, angle 5 plus angle 6 have to equal to 180. And I know angle 5, right? It's 110 degrees. It was given to us to begin with. You could have used any of these other angles for supplementary work, but I'm just using angle 5 because it's the one that was given to us to begin with. So then we're just going to subtract 110 from both sides. And it tells us that angle 6 is just 80 degrees. It's kind of like very similar to, oops, I'm sorry, not 80, 70. Math doesn't work out too well right now in my brain. Okay, so angle 6 is 70 degrees. So I know that angle 6 is 70 degrees. So the angle opposite to it, which is angle 7, is, so angle 6 is 70. Angle 7, which is opposite to 6, is also going to be 70. Then the corresponding angle theorem. 6 and 2 are corresponding. So angle 2 is also 70. And 7 and 3 are corresponding. So angle 3 is also 70 degrees. And that right there is number 2. Again, we use the vertical angle theorem, the corresponding angle postulate, and the supplementary angle theorem to find every single angle here. All right, moving on to number 3. So number 3 says you have a situation here where, again, I'll quickly draw it out. You have two lines here, L and M, so L and M, and N and Q, which are going to be parallel, and they're being cut through by a third line. They did not label a third line, but it doesn't matter. We don't need that. So 1, 2, 3, 4 are the angles that are formed. 5, 6, 8, 7. Here I got them on different sides. Doesn't matter. Those are the 8 angles. And it says if L and M and N and Q are parallel, which theorem proves that angles 3 and 6 and 4 and 5 are congruent? So 3 and 6 and 4 and 5. Which theorem says that these angle pairs are congruent or the same? Well, they are on the inside. So right away that tells you it's going to be the interior one. And they're alternating. One is on the right, one is on the left, right? So this is going to be the interior. So it's going to be the alternate interior angle theorem. There you go. That's the answer to number 3. Very darn easy. They're on the inside and they're alternating, so that's the theorem that proves them right. All right, let's move on to number 4. Number 4 is similar. Let me draw this out. Again, you have two parallel lines given to us. C is parallel to A. Sorry, CA is parallel to ED. Those are two parallel lines that are being cut through by a third line, which forms the 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. And they're asking us which theorem proves that 1 and 5, 1 and 5, and then 4 and 8 are going to be congruent or the same. Well, this can't be either the interior or the exterior because some of the angles are on the inside, some are on the inside. Like if you look at 1 and 5, 1 is on the outside, 5 is on the inside. 4 is on the inside, 8 is on the outside. So, yeah, if they said 1 and 8, that would be alternate exterior. If they said 4 and 5, that would be alternate interior. But they're asking us for 1, 5, 4, 8. These are going to be corresponding angles. And this is the corresponding angle postulate. Postulates and theorems are pretty much the same thing. So this is the corresponding angle postulate, if I'm not mistaken. Yes. So that's the answer to number 4. Pretty darn easy, I'd say. Because these angles are corresponding. They're essentially, if we were to take this right here and this right here and just move them onto each other, these essentially would drop onto each other. They would be the same. 1 and 5 would be the same, 2 and 6 would be the same, 3 and 7 would be the same, and 4 and 8 would be the same. That's why. All right, anyways, so let's go ahead and move on to number 5. Number 5 has this particular scenario. So you again have these two lines that are parallel to each other. And that's BC is parallel to GH. And they're being cut through another line, which forms us the 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. And the question is, if BC is parallel to GH, according to the alternate exterior angle theorem, which angles are congruent? Well, it's going to be the exterior angles, first of all. So which angles are exterior? It's 1 and 3 and 6 and 8. Those are exterior. Now, which are alternating? Up, down. So 1 and 8. So you can say 1 is equal to 8. And then, again, up, down, 6 is equal to 3. Or, 8 is equal to 1 and 3 is equal to 6. Doesn't matter which side. But it's 1 and 8 and 6 and 3. Or 8 and 1 and 3 and 6, whichever way you want to think about it. That's the first part. Then it says, according to the corresponding angle postulate, which angles are congruent? All right, that's a little different. So for corresponding angles, it's going to be angles 1 and 5, right? So angle 1 is equal to angle 5. It's also going to be 2 and 6. So angle 2 is equal to angle 6. It's going to be 3 and 7. So angle 3 is equal to angle 7. And then it's going to be 4 and 8. Angle 4 equals to angle 8. I should have probably color-coded them a little differently. I'm actually going to do that. The numbers are right, but I'm just going to color-code it so give each pair its own distinct color. So yeah, 1 and 5, I'll keep that as blue. And then 2 and 6, so angle 2 equals to angle 6. This is all part of the second part. Then it's going to be 3 and 7, so angle 3 equals to angle 7. And then let's do this, angle 4 and angle 8. So angle 4 equals to angle 8. And this is because of what I did before. If you squish the two together, so if you were to squish these two like sections together, they would just lie on top of each other. And the angles would essentially align. So I'll just break these up like this. The top is the first half and the bottom is the second half answer. So that's number 5. And number 6, which I think is the easiest problem of the bunch. Let's see here. You have two lines that are being crossed like this, which forms us 4 angles. 1, 2, 3, 4. And it says, according to the vertical angle theorem, if angle 1 is 60, so if angle 1 right here is 60 degrees, what are the other angles? Well, according to the vertical angle theorem, the angle that's opposite is the same. So this is also going to be 60 degrees. So angle 4 is 60. Now, what do you do for angle 2 and 3? Supplementary angle theory. 2 and 4, or 1 and 3. So like angle 1 plus angle 3 have to equal to 180. And then angle 2 and angle 4 have to equal to 180. And I know angle 1 and I know angle 4, right? So here you can say that 60 plus angle 3 is 180. Oof, that's a horrible 8. And here you can say angle 2 plus 60 degrees equals to 180. In both cases, you would just subtract 60 from both sides. And in both cases, you would find out that here angle 2 is 120 degrees, and here you would find out that angle 3 is 120 degrees. So those are your essentially 3 answers. Angle 4 is 60, angle 3 is 120, angle 2 is 120. Using with the vertical angle theorem as well as a supplementary angle theorem. And that's the entire quiz. Thank you.